All right, here we go on our isotope lesson, or is it isodope lesson? What is an isotope anyway? Well, it is the same. Yeah, just kidding. Okay, they are the same element, but they have a different mass. So, carbon has different isotopes. We have carbon 12, carbon 13, carbon 14. It's referring to the different mass of the element. So there's two different ways that we can write it. We could say that we have carbon 12, or we have carbon 14, or we could write it out and just use the name. We have carbon 12 and carbon 14. When you see these numbers, they're referring to the mass of the element. Okay, so how do we determine information based on the isotope? Here you have in number 3 and 4, two different isotopes of chlorine. I want you to determine the information about chlorine 37 and chlorine 35. When you're looking at it on the periodic table, the atomic number for chlorine is 17. This has chlorine 37, so its mass number is 37. The number of protons equal the atomic number. These are always equal, so it has 17 protons. And for our purposes right now, protons equal electrons, and so there's also 17 electrons. Neutrons are getting by you get those by taking the mass number minus the protons. So 37 minus 17 gives you 20. This isotope of chlorine, chlorine 37, has 20 neutrons. And so how would we write that? We would write that 37 chlorine, and its atomic number is 17. All right, so chlorine number 35 has the same atomic number. Now, chlorine 35 has a different mass, so its mass is 35. It has the same number of protons because remember, that's what makes the element, the number of protons that it has. I didn't say anything about a charge, so protons equal electrons. This one has a different number of neutrons. So 35 minus 17 is going to give you 18 neutrons. So this chlorine is 35, still has the same atomic number, and chlorine. Now, remember, if there were a charge, it would be right up in this area, but we're not on electrons. So what is average atomic mass? Average atomic mass refers to that number right there. And that is basically the sum of all the masses. I don't really know if masses is the right word. Of its isotopes multiplied by its natural abundance. So essentially, we've paid scientists to go around the planet and capture different elements and put them in a machine, and those machines tell us that so much of the carbon on the planet is 12, so much of the carbon on the planet weighs 14, and so we get an average atomic mass, which is the total of all those masses when you multiply them by their abundance. Okay? So how does the abundance of each isotope affect its average atomic mass? And, well, the average atomic mass is usually closest to the isotope that's most abundant. For example, here I have silicon. Silicon's atomic number is 14. That's its average atomic mass. So the number 28.086 is most closest to 28. So I have silicon 28, and silicon has another isotope. Can you guess what it is? It is 29. And the most abundant isotope of silicon is 28, because 28.086 is closer to 28 than it is to 29. So what does the average atomic mass on the periodic table tell you about the elements in nature? And that's really just who is the most common. I mean, we know that silicon 28 is more common than all of its other isotopes because the average of all of its abundance is closest to 28. So what are the steps for calculating average atomic mass? And that's basically calculating this number. What are the steps? Essentially, you're going to take all the masses of the isotopes. So mass, you're going to multiply them by their percentages. You're going to get a number. Mass of isotope, another isotope, by its percentage, and you're going to get a number. And then you're going to total that number. So that's how I get the mass of the isotopes multiplied by its percentage totaled, or the sum of the mass of the isotopes by their percent abundance. That's what the definition means. Okay, honestly, the easiest way for me to do this is to probably show you how to work out a problem here. So calculate the average atomic mass of oxygen. I have oxygen 16. Oops. I need to rewrite that or I'm not going to be able to read it. Oxygen 17 and oxygen 18. Oxygen has these three isotopes. It says that oxygen 16 is 99.76% of the oxygen on the planet. Oxygen 17 is 0.04%. And oxygen 18 is 0.20%. Okay, so mass, which is right here, times the percent, it's going to give me a number. Now, before, you could just put this in your calculator and use the percent button, but if you don't know how to use your percent button carefully, then I want to point out something. Percentages are multiples of 100. So you have to move the decimal point over 2 places to the left if you're not going to use your percent button. Okay, I'm just pointing that out. So 16 times 99.76%, right? I get 15.96. 17 times 0.0004 gives me 0.0068. And 18 times 0.20% or 0.002 gives me 0.036. I'm going to total those up. I get 16.0028, and the units for this are AMU, atomic mass units. And so this is my average atomic mass of oxygen. Now, this number is different from real oxygen, right? Because when you look at it on the periodic table, oxygen's mass number is 15.999. So sometimes in these problems, they're not going to match because that's how we know you're doing it right. And for my famous isotope joke, what did the scientist say when he found 2 different isotopes of helium? He said, hee, that's funny.